Hi, everyone. Thank you so much for attending today's roundtable on anti-money laundering with Fibo, ML, and Graph. My name is Laura. I am the host today. Before we get started, just wanted to go over a few items with all of you. There will be time at the end of the webinar for Q&A. So if you have any questions, please leave them in the Q&A box at the bottom of the Zoom meeting, or feel free to chat the panelists. We are recording today's session, and I will be sending out a follow-up email with the link later this week. And also, if you have any questions or issues, just feel free to message me as well, Laura, Expero Internal, and I'll be happy to help you out. We hope you enjoy today's presentation by Expero. And with that, I guess I'll hand this over to Scott Heath.
Hello, everyone. Very nice to see everyone virtually these days. On our next slide here, what we'll see is our agenda for today. These are the folks that are going to speak today. I'm Scott. I'm part of our graph and analytics team. Dr. Granzel and Mr. LaCava will be sort of rounding out the show here. What our goal is if you followed us here on the next slide from an agenda, we started this off at the beginning of the year where we did a vision webinar. And if you can go back and look at that. And what we did there was talk at a macro level and also invited some of our friends at the EDM Council. But today, I'll be touching on a few of those and what are the real sort of complexities at a lower level is what our goal is today. Chris will then sort of walk us through how does this work from a human, how does this work from a level 1 investigator all the way to an executive down to a level 3 investigator or even a machine learning team member. And so Chris is going to give us an art of the possible and show us how we would address that. And then finally, Graham is going to round out specifically, how did we do it? What are the details of it? What are some of the different elements or components that do that? So pretty excited about today. And without further ado, we'll sort of jump in. So on the next slide, what everybody is seeing, and for those of us that are practitioners, is it's no longer a straight line of we're just going to go look for money laundering. It's now this complicated component of what's really going on here. It's a large number, obviously, as we're seeing here from the United Nations on drugs and crime. It's not just the movement of the money, it's the total number. It's now some of the different elements that are coming in from OFAC lists and sort of what we're getting fined for, again, out in the banks, or even if you're a transfer service, et cetera. And so I think, the takeaway here is that it's becoming more difficult. And as we see in the little pictogram over on the left, people may be starting in cyber and ending up terrorist financing, or they're round tripping drug money, et cetera. And we don't even see on here the idea of human trafficking and some of the ancillary ones. So I don't think anybody is of the opinion that it's getting any easier. But really what we see then is here now in 2021, it's getting bigger, it's getting more complicated, and then the layering or the non-obvious linking is really, really getting fairly complex. Our adversaries are sort of upping their game as we up our game. On the next slide, what we can start to see now is, look, it's a large number. The trillions of dollars that are happening and where it's happening is really in no dispute. What's happening now is, for those of us that are doing this, is it's crossing over. So we see retail, we see the Amazons and the Walmarts where people are buying things and then returning them and using gift cards to launder the money. We're seeing money transfer services where those things are making multiple hops in a day, and they're hiding their trails. The other thing that we're seeing then is it's not just banking or account management. They may also be doing some of these other kinds of things like the human trafficking, et cetera. So being able to have a systematic and a technology approach that allows us to share bank to bank, share bank to wire service, et cetera, becomes now high on our list of things to do. And so what we'll see today, both Chris and Graham will sort of walk through how we start to connect those dots. The other thing then is reconstructing this history of bitemporal, of what happened when, is as important, not just simply saying to the human, this is a risky behavior. It's who knew what when, so that we can now recreate this in a much more definitive way, so that we can either prosecute or we can share with either our state, local, and federal law enforcement what those behaviors may happen. And then, as we mentioned now, is it linking a credit card transaction to a money laundering or an account, or somebody who's on an OFAC list, et cetera? It's this combination of use cases as we get into it. And then when we look at new customers, so either my current set of customers or my new customers, are these new people coming in? Are they really just synthetic IDs? Are they adding on to existing ones, et cetera? And then finally, I've got to put this in a humanistic way. I've got to take all this great technology we're going to learn about today, but I must do it in a human way where it makes sense. And not everybody in the operational chain for investigation knows or cares about some of the technology. They need help on sort of lowering the false positives and really helping them increase the workload that is now sort of built up on them. Our next slide, what we now see then is, let's break that down even further. So over on the left, if today we're going to talk about anti-money laundering and then sort of how this sort of lays in, but all of these other use cases. So whether you're an internal fraud, and so whether you're looking at AML where internal folks may be coordinating inside of your bank or your organization, or there's other kinds of things like credit card fraud or false ID or cyber, right? Those are other entryways that may affect AML. They may or may not affect that. And so I think it's important to take note of those, because what we're going to see today, all of very similar styles of what we're going to do here in the middle, which is the visualization, showing how these things link together, show the non-obvious relationships, the dependency, and that ability to do that for a lay person is just as important for all of the use cases on the left. And then finally, over on the right, which is, how did we do this? How did we look for patterns? How did we find existing patterns? What are good patterns and bad patterns? Teaching the system to help the human, and then ultimately surfacing that in a way that people can understand, depending on who your user is. So what we've done now is we've kind of lowered it down now a little bit. So hopefully, what we're going to talk about in the use cases here over on the left, you'll start to see the two categories in the middle and over on the right. On our next slide, what we see now is this sort of drawing those use cases over on the right together. You see the hard lines and the dotted lines over there. So again, this concept of AML, it may have multiple links to fraud rings or not. It may have device or cyber or compliance or regulation right over there, et cetera. We may also have links to customer 360, right? We may have know your customer, where we're using that data almost as a positive pattern to look against what's not normal as a negative pattern or what could be fraudulent. And then all the way over on the left, we see that our key business users and our executives they want to stop spending money in sort of savings, right? They want to stop it before it starts. They also want to potentially increase the revenue. So every time I stop a credit card or stop somebody from their account or usage, that may be a good usage, and that customer may not spend money with us, which is bad, right? So I'm actually it's a dual kind of a use case here, is that I'm stopping the fraud, which is losing money or getting a fine, and I may actually be stopping good activity. And then finally, at the bottom, nobody wants to go to jail. We'd like for our prosecution rates to be high, and we want to make sure that from a compliance and regulatory that we're in that. Now, one of the things we've learned about some of the new things that are happening this year is that it's increased the scrutiny, right? So these use cases now have taken on a new complexity, given that now the lowering of the amounts that we now need to start looking for SAR reporting on, as well as sharing with other banks and those kind of things. So it really sort of underlines these kinds of use cases. On our next slide, what we see now is these have not changed, right? We must increase our accuracy, right? So we've got to move it up today. Many of the ones that we'll see here in a minute are at a baseline with the addition of machine learning, but we always are chasing a higher accuracy. The second item then is, how do I use what I have today? Most everybody on today's session is already doing something. It's not like you guys have been in a vacuum where you haven't been doing anything. The answer is you probably spent a lot of money. A lot of people have spent a lot of sweat and time bolting on to Actimize or CyberSource, or again, sort of custom systems, et cetera. What we're going to show you today are ways to use what you already have and make it better. Start in a very fast time period and then increase those, which leads us to our other one, right? Which is, not only do I want to make it more accurate, but I actually want to decrease the false positives, allow the human to denoise quicker, allow them to become more efficient. Because at this point, now we're seeing a trend of anywhere from 20 to 30% increase in the cases that were being given, because of the legislation has sort of lowered the bar on what we need to look at. We now need to be even more efficient, right? So I need to be a bit more automated. And then the other big thing then is this changes, right? Each year it changes again, and then the next year, and so on and so forth. And so what we need to do then is create this continuous improvement loop so that the system is learning, the human is assisting that. And again, Chris and Graham are going to show how the human sort of fits into this loop, et cetera. But these again are sort of the truths that are still there. On the next slide, what we see is exactly that. So it's not just the accuracy boost. It's this sort of, what most folks are learning now is that machine learning can be a huge boost. Well, from our experience, what we find is machine learning can be great. And as one of our customers once told us, now I have 15 to 20 full-time machine learning people, which are random acts of machine learning violence. They're helping people in very specific ways. They're boosting it, but that integration and learning from what those different kinds of things are is now kind of our baseline. By taking a graph technology, which we'll learn more about today, and machine learning, we can start to see that this combination, and Graham's going to talk more about that, which is we can start to see now that 6% plus. Then when we put the human in the loop, which is tying what Chris is going to show us now, that ability to take the expertise of a human, a senior investigator, so that now a junior investigator gets that same benefit in the system, now can get us this enormous boost in both accuracy and productivity. In the next slide, what we start to see now is we have two specific cases. Now, these are two of our customers. Your mileage may vary, but what you start to see then is just the accuracy of the detection in anti-money laundering is a huge boost. And you can go down here at the bottom and you can see one of Graham's blogs on sort of how did we do that. Now, in this case, it was a combination of the visualization, it's a combination of the graph technology and the machine learning that got us this boost. The next one that we see then is just purely in the investigation, right? So now that other systems are around this, so we may have an Actimize or, FICO or any of these other kinds of systems, what we start to see then is the increase can still be very high. And so what we want to do now is bring this good news on the next slide, which is now what we'd like to do is up the game. We see these different sort of third-party data elements. Now, what we want to talk about today is this idea of taking these white or gray lists, whether it's an Open Corporates or a Moody's. Let's take the fact that we know a corporation has been around, there are emails, there are things that we know and or people that we know that are considered good. Now, are they complete known to us? There may be a gray component, and then your own internal data may enrich that, but we now at least have this sort of first category. The second one is you may already have a risk or scoring system. This may be happening at a transaction level. There may be custom systems that you have enabled, et cetera. What we now want to do is take those signals and we're going to combine them with the whitelist, and then finally down at the bottom, the blacklist, which is ultimately the Treasury and OFAC and FinCEN are giving these data elements of people and perhaps political connections and countries and those kinds of things. If I take the recipe of these, Graham's going to talk a little bit more about how now I can increase my accuracy with the combination of some of the technologies we're going to see today. On the next slide, we see a bit of a sort of a backdrop. So now that I have all this great data, where is it going? It's going to go into and our friends at the EDM Council, this macro data model, or ontology as it's used in its vocabulary. But what we can do now is, if we have a standard sort of landing data model or ontology, we can start to do some very, very powerful things when that data comes in. So as we flag things, we identify things, we can become infinitely smarter by using a similar concept, especially if we're sharing bank from bank. On the next slide, we see now basically how all these things fit together. Now, Graham's going to go over this. This is a higher level version. And what we see then is we would use each customer's data over on the left. We can use the scoring system. And again, if you don't have one, that's not a bad thing. You may have something that's perhaps not terribly rich. Maybe you do. And so again, that just becomes a good signal as an input to go do that. We use our white and our gray list, and then finally our black list. By connecting that data, Graham is going to show us later how those things really fit together. Then we drop it into our Fibo data model, and we're able to now create this risk and scoring that Chris is going to show us of how easily it is now for the human to take all of these sort of complex items and then see it in one place. On the next slide. Okay, so that's really kind of what we have on the table today. So what we've done now is we've sort of set that sort of expectation. And now Chris is going to walk us through sort of how does the human get involved, and then what do they see from that kind of pictogram, if you will. So Chris, over to you.
Thanks, Scott. Okay, so Scott mentioned this earlier very briefly, but there are a lot of different types of investigators, a lot of different levels of information that people need access to. We're dealing with very complex, large volume data. It's very time sensitive, so a lot of times they have to make decisions very quickly, and it's highly connected. So the complexity and the sheer volume of it means that it's very, very hard for humans to process. And there are level 1, level 3 investigators that have to interact with this at varying levels. So we have to basically customize their window into that data set to meet what their objectives are. And I'll show this in a couple of lab demos soon, but basically the tooling around accessing this data matters, and the level of complexity that you reveal and progressively disclose is really where the usefulness versus complexity comes into play here. So there's a process of progressively working through identifying, gaining visibility into the data, identifying patterns, and then being able to analyze it, and then eventually working it through the entire life cycle of the investigation and closing it or bringing it to a terminal end. So first of all, we need the ability to find the needle in the haystack, and that's there's a lot of tooling around looking at that high volume of data to be able to recommend certain things for people to look at, and we'll look at this in the live demo in a minute. But there are ways to basically build filtering and other types of ways to be able to peer into this data and pluck out the things that need attention. Then there's a process of managing this stuff, going through levels of approval, and then making sure that you're building a case. If it leads to something like prosecution, of course, there needs to be a lot of a paper trail basically to follow that and audit. And then once you basically recognize a pattern, there's things that you can proactively put in place to catch things early. And then once you've built this system, you can systematize or operationalize the interaction with the system. And so that's kind of the life cycle of how we look at these things. And a lot of the tools that I'll be demoing show different aspects of that life cycle. So there's a lot of different teams involved in this, and I think this slide kind of shows some of the complexity of that interaction. But this is a collaborative, approval-based system. So there are a lot of different entities looking at a data set to try to identify fraudulent activity at any given time. And like I said, the window matters. So they all have similar but distinct goals, and they intersect this data at certain parts in the life cycle of that investigation. So they're all looking basically at the same set of data, but that view matters, and the level of complexity matters is basically the point that we're trying to get across here. So as I mentioned before, visibility is the first step. Being able to see from a bird's eye view what the situation is, find the interesting points, and then zoom in on those, progressively disclose those details at that point. And we deal with highly connected data, in some cases graph-based data, and the sheer level of connections is pretty daunting. It's something that you have to manage from a user interface standpoint for it to be usable. And then, displaying the data doesn't always have to be a complex visualization. A lot of times people are working prioritized lists. So using just tabular data, basically co-visualized with more enhanced data visualization, is a tactic we often use to be able to bring that complexity of geospatial data or a network diagram if you're looking at a ring of fraud, for example, but co-visualize that with tabular data. And again, I'll show that in a few minutes when we jump into the demo. And of course, a lot of these things have, the location that they take place is a clue into being able to unravel some of the connections in bad actor activity. So geospatial and temporal views are always instrumental in investigating things, and we have a few examples of those as well. And as I mentioned before, temporal is a big indicator a lot of times when you're trying to see patterns of behavior, especially, but also just laying out the chronology and how different actors intersect in that chronology sometimes gives you a pretty good indication of what the types of patterns of behavior that you can basically proactively prevent if you can reveal them. Okay, so we'll jump into a live demo here in just a minute, and I'll go through some of the pieces that we've discussed so far on how to basically build certain mechanisms to be able to, first of all, introspect this data, and then second of all, be able to build mitigation controls around it. Okay, so on the level of visibility, we're looking at a pretty standard dashboard view here. We've got the major dimensions of the data that we would like to slice this by. So we're basically looking for patterns of fraudulent transactions. We can slice that by region, by country, and we can even look at things like transaction type or other indicators that will allow us to look for correlations in the data. And the dashboard is basically giving us that high-level view of just where activity is, so we can click through to see more detail. How these alerts actually get on this screen is interesting, and something I think Karen will mention in a little bit. But we can basically build a set of filters, a net, if you will, to cast out and find certain types of interactions that we're interested in. So what I'm going to basically do is build an alert trigger. That alert trigger will send out basically a set of filters, and as transaction data comes in, it's going to go through this filter that I've set up, and if it detects things that I've basically described, it will put those transactions in places like a dashboard, so then investigators can go and work through that list of triggered transactions to verify whether they actually are fraudulent or not. So I'm going to build a new alert trigger. I'm going to set effective dates here and set the priority of it. And then I'm going to add some criteria to it. So in this case, I'm looking for a specific place. And let's go ahead and add a high risk place here. We'll say, for the sake of argument, it's going to be Mexico. And I'm going to save that criteria. And then I'm going to add another one and say or. And this will be another place. And I'll add criteria here. I'm going to select a region as well, but this is going to be a very specific region. So I'm going to zoom in here, and we'll say I want transactions between Mexico and we'll say southern Texas, this southern Texas area. So I'll save that criteria here. And then I'm going to add one more. And let's say that I'm looking for certain transactions. So I want to look at amount and frequency. So I'm going to say a minimum of $5. So we'll say to $10,000 per transaction. And then we'll say we're looking really for frequency now. So within 5 days of each other. So it's going to basically look at a quick burst of transaction between the two places that I've noted here. And I'm going to save that. And I'll set up my logic here. So it will be those two places and the transaction amount. And then I'm going to set some actions for when that alert actually triggers. So I'm going to say route for approval, and I want this to go to my escalation team specifically. And I also want the data grouped by certain triggers. So I want to basically bring it to the attention of this escalation team. And then I want to be able to group it in a certain way so it's presented in a way that they can quickly see what the situation is. Okay, so my trigger is saved. I'm gonna go back to my dashboard here. And that will come into various queues if that trigger is hit. And then my escalation team can go through and work those transactions. They can look at their queue, their transaction queue, filter it through here, and basically see the list of transactions that have come in from there. They can click in on the details of a transaction and see some of the connected data around, what credit cards are attached to those transactions, what devices, some basic characteristics of other things that are other information that's adjacent to it. And they can either mark it as this is not fraudulent, or they can escalate it. So there's a path to escalation here. They can add comments and basically build the case around things that they found with this transaction and attach it to other transactions as well. Build a portfolio basically of like things. They can even drill deeper into this information. So if they want to see this connected data in a more interactive graphical way, they can actually say, let's see here. They can actually look at an investigation and all of the adjacent information across it. And they can drill into bad actors, for example, and see how they're connected to other things. And they can even search for other information that may be connected to this case. So they can start to build that investigation connection schematic, if you will, to basically serve as a graphical representation of how they're traversing that data. And they can click on anything in here and gain more information at a glance here. So they can drill into the attributes of these sorts of investigatory patterns, and then they can basically build their case from there. They can also view this in geospatial terms. So if I want to see the same information on a map, I can do that. And I can always look at it from tabular information. So you can start to see as we go through these different views that this, everyone that touched this investigation would not necessarily build an alert from scratch. They wouldn't necessarily traverse the data in a graphical form. They wouldn't necessarily see it on a map, all under the same persona, but different aspects of the investigatory team would use these tools in certain cases. So maybe a more senior investigator would build the alerts themselves, and then they would have a team that would go through and be the first level of investigation to basically see if there is clear fraudulent information. And then from there, that can escalate and go through the approval chain, as noted. Or if a certain pattern triggers, that has to go directly to a special team that deals only with escalations, or a senior team that looks at things from more of a geospatial standpoint, that can happen as well. And we can start to build transactions that are connected to each other through data visualization in this manner. And then we can start to see those non-obvious connections that Scott mentioned, and Graham will talk a little bit more about how to discover. So that's just a quick tour of how we view the sorts of information that Scott referred to in basically the preamble to the demo. And I believe Graham will dig in a little bit more in-depthly on how we can actually use leverage technologies to aid views like this, and enable investigators to look at things that under legacy systems may not be obvious. Okay, Graham, over to you.
Thanks, Chris, and thanks for the intro earlier, Scott. I'm going to jump into some of the details of how the technology supports these use cases and analyses. As we look at the market here in 2021 and on into 2022, I just want to show some methods here today about what things are up and coming and what things are going to be most the analysis further. Hey, and I'm back. So apologies for the spotty internet here, but I just wanted to mention here the difference between what we consider to be data products and data projects. So the technologies I'll be discussing today are fully deployed, they are autonomously updating, and they operate in real time. These systems are the types of systems that enable real-time analytics without the manual intervention of a data science team. Although at a certain cadence, organizations do typically include their data science teams when they're upgrading these systems, or perhaps including new data sources, those types of things. So let's have a look at the logical view. The flowchart here goes from source data, wherever you're ingesting that data from. Could be in-house databases, could be external sources. I'll mention some other systems in a few slides, like CyberSource and Actimize, all the standard fraud solutions. Getting that information into a network structured relationship, and then performing analytics on top of the graph structured data set to give you better insight into what's going on at all of the levels, including the transactional level and the customer level, including individuals and corporations. So with that, let me just show you here. We'll step into the first section here, which is, why is our method the best method to get these pieces of information into a relational structured format and into a graph structured format to understand relationships, as I mentioned before. What this looks like across organizations is a gigantic schema called the Fibo Ontology, put forth by the EDM Council, which I'm showing here on the next slide. This is a big representation of all things financial services that helps companies exchange information between entities. So this could be service providers, it could be financial institutions. The point is getting this information into this functional format where you're no longer looking at, let's just random rows in the database. You're actually looking at the functional relationships between, let's say, investor and instrument, or bank and loan, those types of relationships. It is a big hairball of ontology, and you don't always need all of it. So I've just picked out a couple of details on the next slide to look at the individual relationships we'll be talking about for the anti-money laundering fraud use case. Interestingly, these subsets also service a bunch of other fraud use cases too. So if you're interested in that stuff, please do reach out after the webinar. This is what it looks like from a detailed level so that we can understand who our customers are, both from an individual level and corporation level, who their accounts are, what the transactions look like between all these entities, and then demographic information like where they exist, what type of business do they do, all those types of characteristics. So on the next slide, we have an actual extract from a very simple database that we've used in the past as a schema from a graph database. We've used in the past to perform anti-money laundering fraud detection. And as you can see here, there are highly connected relationships between transactions, bank accounts, individual people, companies, and physical localities as information sources. What we show here is that as we deduplicate the records in that ingest, and you can see how we're doing that here in two different ways, starting with the next slide, we're able to build up a representation of these entities that allows us to do this analysis, this fraud detection in a much more cohesive environment, because we can see everything about the company or the transaction or the individual. This is the machine learning component of the entity resolution piece to get information into the graph structured format in a way that gives us a full 360 view of that customer and interestingly of that transaction too, or that bank account. And the next slide shows the second component within this intelligent entity resolution, where we use graph information itself to perform that deduplication. And what you can imagine here is, and I'll show an example of this in a couple slides, we have some information. We have a lot of information as an organization about all of our customers. And when we structure that information here in this graph format, we're able to automatically see those connections. And it becomes very obvious who are the same entities, whether or not those disparities come from disparate data systems, like for instance, if invoicing and loan origination systems are on distinct data structures, or in the case of fraud, especially anti-money laundering fraud, where we have an active participant in the obfuscation of those records. Of course, the people performing these fraudulent activities are actively trying to evade our detection. So what do we do once we have information here in that graph structured format? Well, we see this next step here in our logical flow, where what we want to do is perform entity matching. And I have called this out separately and distinctly from the entity resolution piece, because it's important to note that these types of methodologies don't necessarily just include mastering of data. They also include detection of known bad actors or known good actors inside of your organization's data structure. And one of the ways we do that here, looking at the next slide, is what I just mentioned, by looking at the connections. And this is a very simple example, of course. I can't show the entire ontology here on a slide. It's just too much data. But what we show here, of course, is the connected attributes of each one of the people on a target list or companies on the target list. Specifically, as I mentioned earlier, we ingest data from a variety of data sources, both internal to your org and external. Lists, for instance, like the US Treasury's blacklist corporations, the so-called OFAC blacklist, understand globally, what's going on across the financial services industry. Should I be aware of these organizations, and explicitly also individuals who are on that list, to be able to surface a flag to our user that says, hey, this person came up on a blacklist search, and you might want to just have a look through there and see if you concur or not, whether this is a real thing. So let me just circle back to the ontology again here, to the data structure, and show you, again, we already looked at this picture, but let's just look at a little bit of a deeper level to see what we can do next. So we see here companies represented on the left-hand side, people represented on the right-hand side, and accounts, transactions. We have jurisdictions of operation. The interconnections between all of these entities is what allows us a very crystal clear picture of who these entities are and whether or not they should be flagged. It's no longer just, let's do a select statement to see if a name popped up on a blacklist. It's, hey, we can actually tell who these organizations are. We can tell who these people are because of their known interactions in our world and in the external data world. And using a series of algorithms, which I have just a random list of on the next slide, we're able to understand various contextual behaviors about those entities. So on the left-hand side of this slide, I'm showing some graph algorithms. On the right-hand side, I'm showing some machine learning algorithms. It's important to recognize that these things work together, and you're going to deploy all of these, or a big majority of these, or even more than I'm showing on this slide. And what you'll find by deploying these algorithms is behavioral or contextual relationships between the entities in your data structure. And that's really critically important, because as we move here into the last step or second to last step in the logical flow, where we're actually performing that data analytics, we want to know not just based on what we know about an individual person, like has income over 50,000 USD per year or something like that, which is important, but is admittedly a very small step. We want to know who that person is. We want to know what they've done recently. We want to know who they're connected to and what companies they've exchanged money with. We want to know what types of bank accounts they touch regularly. These graph and machine learning algorithms allow us that look into the contextual patterns of actual day-to-day operations of the people that and organizations we care to serve. So let me do one quick tech slide here, and apologies if this puts you to sleep, but this is how the actual mechanics of the graph machine learning algorithms work in concert. So we start with the full graph structured data database. We pull out isolated subgraphs, so little components out of that huge database of records that you have across your organization. And we use those so-called eographs, or sometimes multiple at the same time, and inject those into our machine learning algorithms, our graph machine learning algorithms. And the analysis is then surfaced, as you can see here in real time, into a front end. And that allows our human fraud analysts or investigators to be able to make decisions based on concise aggregated information. The architecture looks like this. So we've got another slide here showing the actual inner workings of how all the mechanisms in the system interoperate. At the top of the slide here, I'm just showing multiple data sources, but in that big white box labeled data model, you can see that we can and do use a ton of different detection methodologies. And some of those methodologies can be things that you already have in place, and they almost always are. So if you're using a system in your org today, like Actimize or like CyberSource or something similar, we ingest that information. We use the judgments rendered by those systems in aid of our holistic hybrid fraud detection system here. And they all work together, and the combination of having all of that information at hand is really important, and it really makes this thing super, super advanced. It makes the accuracy really high. What we see at the bottom of the slide, which is just as important as that high accuracy system using that hybrid detection methodology, is the ability to keep those investigators or analysts directly in loop with the algorithms, in loop with the data that's going on real time, to be able to make domain expert opinions and judgments about what's going on boots on the ground. So if this system surfaces a flag that says, hey, analyst, this is likely money laundering. We've detected a situation here that you should look at. That analyst can choose to say, okay, thanks. Yeah, this looks like a bad deal, and I'm going to dive into this further. Or the analyst can say, well, no, actually, that's a bad recommendation. And on the next pass, when I log in tomorrow, I want you to understand why that was a bad recommendation, and take that into the machine learning part of this system will actually learn from that domain expertise, that specification by the analyst, so that it actually understands the next time the algorithm is run, whether that's an hour later or a day later, whenever the analyst log back in, they can use that information. The system uses that domain expertise to upgrade. Okay, so let me just, before we jump into what this looks like in practice, let me do one more slide here on the sort of pillars of what's going on behind the scenes. And this is the list of stuff that we see happening here in 2021 and 2022 in terms of advancing the anti-money laundering and other types of fraud detection. Those technologies depend on these four. So we have monitoring of systems. And this is a specialized kind of monitoring, as we mentioned before, that monitors for discrepancies between inaccurate results served by the system and what's actually going on and what our expert users know to be true. The second is the ability to actually implement these solutions and upgrade them seamlessly and at a very fast turnaround. And the third thing here, the reason we want to be able to do number two is so that we can build this system, as I mentioned before, in a way which automatically updates itself based on what the users are doing. And when you have the first three, what you have is this system Scott mentioned at the top of the webinar that gets better and better over time as your analysts interact with it. The accuracy increases. The exposure to situations allow that system to understand more and more comprehensive details about the actual transactional ongoings of your customers, et cetera, et cetera. The last piece of that puzzle is interpretability. And this is related to the explainable AI phenomenon that's been going around the marketplace here for the last 6 months or so. And what we'll do, and I'll show you in a couple slides, what we do here is we actually showcase the reasoning behind the system's decision-making process to say, this is recommended that you should investigate this transaction or this corporation. Not only that, but here's why. And this is the reasoning. This is why we think that these things are happening. This is why we think that you should investigate. Okay, so the last part of the puzzle, of course, and Chris did an excellent job showcasing these interactions in the demo, but let me just go over some of the visuals and I'll just link them back to the things I've been talking about. We have the actual analytics injecting that into the front end, into the UI, so the users can see what's going on. And then, as I just mentioned, re-ingesting information from them about their feedback and their usage signals to make sure that system gets better over time. So very simply, what this looks like is the following. We have and you may have seen this already if you have some machine learning operations in-house. We have these types of systems which showcase the rationale for the decisions made by the system directly to the analyst. So if the analyst is going through many transactions or investigating or reviewing many corporations per day, they can jump into the detailed screen you see on the right-hand side and then make a decision about whether or not the recommendation is correct and try to learn from the system about why that judgment was made. And what we see in the next slide is a concise aggregated view where we have the connections to known fraudulent behavior so that as the analyst walks through from that bad transaction or from that bad corporation or from that bad entity, individual, they can see what things are connected directly to that and which of those things, very importantly, are known to be fraudulent behavior or have fraudulent context. And when they've done that, and this is the last sort of screen I want to make a point about here, they can provide us feedback. And this is what we see here. So after that analyst has gone through and has said, you know what, actually, it turns out that this system said that this service provider had some fraudulent dealings back 2 years ago. Well, because of that, system recommends I review these sets of transactions. And when I do that, I can say, yeah, that was a good recommendation. Thank you for that. Or no, actually, I investigated. It turns out that everything is normal here. And next time, I don't need to see that type of information. These are the types of feedback I mentioned earlier, which allows the system to upgrade itself, update itself, increase its accuracy over time. And the last point I want to make here is just how quick it is to set a system up like this. The process is iterative. So you can start, as I mentioned, with systems that are already in place for fraud detection, or, I mean, perhaps you don't have anything in place already. That's fine too. This system operates in conjunction with or standalone to other fraud detection methodologies or other fraud detection products, rather. What we see here is a starting point is we have all of the pieces, all the systems of record lined up, as I mentioned before, into that data structure. And then we enable a pathway for the system to get online and update in near real time. And we migrate into the last two phases where as every sprint cycle or whatever the cadence is at your organization, you have a new release which updates the system. And in between releases, as the analysts use the system, it's also getting better. And the monitoring, the interpretability, the understanding and visibility into what's going on inside of your customers, whether those are at the transaction level or at the entity level, you can see all of that stuff in the front end. If you want to see any more about this stuff, there's lots and lots of detail on our website. We have some links here, and just Googling around, you can find this stuff on our site as well. If you have any other questions, please do reach out to me or anyone on the team. I think we have a closing slide with some contact info. Feel free to get in touch. Thanks.
Thanks, guys, for the presentation today. As a reminder, if you have any questions, we do have a few minutes for some Q&A here. So feel free to drop your questions into the Q&A box at the bottom of the Zoom. We did have a few that came in the meantime, so we can start with those. Graham, it looks like one came in for you. What kind of data and how much would I need to do a POC?
Good question. This is one that comes up all the time. There's one quick answer, which is if you are doing any type of fraud detection or fraud prevention right now, you already have enough data. The other answer is if you aren't doing that already, we need enough data to be able to see some of your customers, and we need enough data to be able to understand their relationships to transactions or to other entities in your data structure. Of course, we supplement with external data, and so we don't need as much as you might think. And commonly, we start with very small amounts of data, literally in a demo context, down into the just kilobytes worth of data. So not very much at all.
Thank you, Graham. Let's see, another one came in. Chris, I think this is for you. Can these visualizations connect to my current systems, like Actimize, for example?
Yeah, Graham kind of touched on this a little bit, but the systems that we demoed here and the other solutions that Expero constructs they're able to stand alone. They're able to be standalone applications, but they are also designed to live within the ecosystem of current systems. So wherever the source of truth data is, the system can ingest that, and it's designed to look across multiple systems and basically homogenize that data in a way that we can visually represent it in the visualizations that that we showed today.
Thanks, Chris. And then we have one more that came through. Scott, it looks like it's for you. How long would we run a POC to decide if this works for our team?
Well, there's two versions. So if we wanted to do more of a t-shirt sizing, as we call it, that can be as fast as a couple of days or a week. If we want to take a walk with real data, that is many times in the 4 to 6 week time frame. Chris showed you the functionality. Graham showed you the construct. What we would do then is figure out how close it is to what that is. Obviously, the closer is the faster. But certainly doing some of those other elements are important, like ingesting other data systems, et cetera. But we, on the whole, typically 6 weeks is the max that we see in that time frame, and certainly reach out to us as, again, your data will really sort of be the limitation. Now, we also can do it with synthetic data. We can do it with concocted data, where we can have you build some information and then we go find that kind of information. So there's certain ways that we can do this where we don't actually have to touch actual PII data or behind the firewall, but we can certainly do it in many different ways.
Okay, great. It looks like that was all for the questions today. Just as a reminder, the session was recorded, so I'll send out an email later this week with the recording. If you have any questions, please feel free to reply to that email or send us a message to anyone on this contact screen. Thanks again for joining us, and have a great rest of your week.